We live in a world that runs on SQL, right? But what about before all that? Before relational databases were, well, the standard. There was this other giant, kind of working in the shadows, powering our industries, a piece of tech that, honestly, quietly ran the world. And we're talking about a database called Total.
And that's a really great question, isn't it? I mean, we totally take relational models and query languages for granted today. But what was there before all of that? For decades, the actual backbone of huge industries, we're talking manufacturing, finance, you name it, it all relied on something completely different. And yeah, that answer was Total.
All right, so here's how we're going to break this down. First, we'll look at where this thing even came from. Then we'll get into the nitty-gritty of how it actually worked. After that, we'll see why its reliability was just so crucial. We'll also compare its programmed approach to modern queries, which is a huge deal. And then finally, we'll talk about the incredible legacy it left behind.
Okay, first up, let's set the scene. You gotta picture it. We're going way back to the era of giant mainframes, maybe even punch cards, to really get where this industrial giant came from.
So Total came about back in the 1970s. It was developed by a company called Syncom Systems, and it was built for one thing, really, the dominant computing platform of the day, the IBM mainframe. Its whole reason for being was to chew through these massive, super complex enterprise workloads, and to do it with just incredible efficiency. And when they built it, they were really focused on three core things. Number one, speed. It had to be lightning fast at processing transactions. Number two, scale. It was designed from the ground up to handle just enormous volumes of data. And number three, control. It gave programmers this really precise, fine-grained control over exactly how data was accessed. Super important. All right, so let's get into the mechanics. How did this thing actually organize and pull data? Because this is where things get really different from what we're all used to today.
At its core, Total was what's called a hierarchical database. So forget everything you know about tables with rows and columns. Instead, picture a family tree. You've got a parent record, right? And that parent can have a bunch of child records, and each of those can have their own children. Everything was connected through these very specific, predefined parent-child links.
So, the big question is, how did you get the data you needed? Well, you couldn't just write a simple query and ask for it. Nope. Instead, a programmer actually had to write code to navigate this tree. You'd literally start at a parent, follow a link down to a child, and then maybe follow another link to a grandchild. The exact path to the data you wanted, it was hard-coded right into the program itself.
And all this navigation logic was written in the big programming languages of the mainframe era. We're talking COBOL, PLI. And what that means is that the database and the application were, well, they were incredibly tightly coupled. You couldn't really separate them.
Now, I know this probably sounds super rigid, and you know what? It was. But that rigidity was also its greatest strength. So let's talk about why this model was just so essential, why it became the backbone for so much of global business.
See, because those data paths were all predefined, Total was just unbelievably fast. There was no query optimizer trying to figure out the best way to get the data. The program already knew the way. It could just tear through millions and millions of records with almost no processing overhead. Just zoom.
So where did you need that kind of speed? Well, think about a factory floor. Total was the engine inside the big ERP systems. That's enterprise resource planning that kept production lines humming 24/7. A part gets used on the line, the inventory had to be updated instantly. No delays, no excuses. Total did that.
And it was the exact same story in finance. I mean, when you're balancing these massive financial ledgers, you need performance that is predictable and absolutely rock solid. There is zero room for error. Total delivered that mission-critical reliability for banks and big financial institutions.
You saw this same principle in global logistics too. The huge supply chain platforms relied on Total to keep the movement of goods all over the world perfectly synchronized. Every single step, from the warehouse all the way to delivery, was tracked in a system that was built for one thing: absolute performance.
So here's the key takeaway, right? Total did not have the flexibility of a modern relational database, not even close. You can just wake up one day, dream up a new question, and ask the data. But for what it was built for, high volume, mission-critical, totally predictable transactions, it was unbelievably, incredibly reliable.
Okay, let's dig just a little deeper into this whole distinction, because honestly, it's the most important thing to understand about Total and its place in history. It was a fundamentally different way of thinking about data. So under the hood, Total was using indexed files, and it enforced these really strict schemas. And that structure, combined with features like segment-level locking, meant it could handle a ton of simultaneous access. It was just perfectly optimized for the mainframe architecture it was built for. It really was a database you programmed, not one you queried.
And this really breaks down that core difference perfectly. With Total, the whole approach was procedural. A programmer wrote the how, the exact step-by-step instructions to get the data. And the result? Blistering performance. Now with SQL, the approach is declarative. You, the user, just describe the what, the result you want, and you let the database figure out how to get it. And the result of that is amazing flexibility. We're talking two totally different philosophies here.
So, as we start to wrap this up, let's think about Total's lasting impact. It's so easy to just look back and dismiss it as legacy tech, right? But that just doesn't do it justice. It doesn't capture how important it really was.
For decades, man, Total was like the invisible engine of the global economy. It was the industrial backbone, doing all the heavy lifting in the background, making sure that the critical systems we all depended on just worked. It was this silent, absolutely essential part of our modern infrastructure.
And that really brings us to this powerful final idea. Calling Total legacy tech completely misses the point. It wasn't just tech, it was infrastructure. Foundational, critical, load-bearing. A huge part of the world we live in today was literally built on top of systems just like this one.
It really makes you think, doesn't it? What other pieces of this kind of invisible infrastructure from the past are still out there just quietly running in the background, holding up huge parts of our world today? Something to think about. Thanks for tuning in.